Hello, my name is Gilbert, and it's a privilege and honor to have you today as my students. Today's lesson will be focused on Group 1 elements. And before we go into the lesson, I would like you to listen carefully to the following lesson objectives. By the end of today's section, my hope is that you will be able to understand and recall all the Group 1 elements. The second objective of today's lesson is that you'll be able to describe the physical properties of Group 1 elements. And then the third objective is for you to know and understand the reactions and reactivity of Group 1 elements. And finally, you must be able to understand the safety precautions you opt to take whilst working with Group 1 elements. Now, let us go into the main lesson. But before we do so, let me give you some background ideas about Group 1 elements. Now, generally, Group 1 elements are all metals: lithium, sodium, potassium, rubidium, cesium, and francium. They are all metals. When these metals react with other elements, they lose one electron from the outer electron shell. During this process, a positive ion with a single positive charge is formed. The ion has a noble gas arrangement. For example, sodium with atomic number 11 and electronic configuration of 281 becomes sodium ion with electronic configuration of 28, and one electron is lost. Group 1 metals are more reactive than Group 2 metals, which have to lose 2 electrons to achieve a noble gas arrangement. On descending Group 1, the outer electron gets further away from the nucleus as the atomic radius increases. As a result, the outer electron is more easily lost. This means that the metal gets more reactive on descending Group 1. The melting point of the metals also decreases as the group is descended. It is vital for you to understand that Group 1 metals, as I've said from the beginning, they are very reactive. Group 1 metals are known as the alkali metals because they form alkaline solutions on reaction with water. The first 3 alkali metals, lithium, sodium, and potassium, are less dense than water and so float when added to water. All react violently with water, releasing hydrogen gas and dissolving to form the alkaline metal, hydroxide. This can be summarized by the chemical reaction or by the chemical equation for sodium and water. Sodium reacts with water to form sodium hydroxide, and the hydrogen gas is always given as a result. All Group 1 ions are colorless. This means that the compounds of the alkali metals will be white in color when solid and colorless when dissolved in water, unless they are combined with a colored negative ion. Most of the compounds of Group 1 metals are fully soluble in water, the exception being some of the compounds of lithium, which are rather less soluble. It is important to remember that most of the compounds of Group 1 metals are fully soluble in water, the exceptions being some of the compounds of lithium, which are rather less soluble. Commit that to memory. Oxides. These react very easily with water, including water vapor, to form the metal hydroxide. For example, sodium oxide plus water will form sodium hydroxide. The hydroxides, these are strong bases forming strongly alkaline solutions in water. They will neutralize acids, forming salts and water. Let's look at the chlorides of the Group 1. These are colorless salts which dissolve easily in water to produce neutral solutions. Sodium chloride is the most common salt found in sea water. The nitrates The nitrates of sodium and potassium decompose on heating to give the nitrite salt and oxygen gas. For example, sodium nitrate will dissolve upon heating to give sodium nitrite and oxygen gas. All of the nitrates in group 1 behave in the same way except lithium. The first member of a group often has unusual properties compared to the rest of the elements in the same group. Thus, the nitrate of lithium behaves in the same way as the nitrates of group 2. Lithium nitrate will break down into lithium oxide plus nitrogen oxide and oxygen. I repeat that. Lithium nitrate will break down into lithium oxide plus nitrogen dioxide and oxygen. The carbonates. The carbonates of sodium and potassium are soluble in water, producing alkaline solutions. They are not decomposed by heating. Sodium carbonate is sold as washing soda and is good degreasing agent. Again, lithium carbonate behaves differently to other group 1 carbonates, behaving like the carbonates of group 2. For example, lithium carbonate will break down into lithium oxide plus carbon dioxide. Now let us go into the main lesson where we'll begin to look at group 1 elements in much details. Group 1 element, these are metals found in group 1 on the left side of the periodic table are called the alkali metals. The elements in group 1 are found on the left side of the periodic table and are called the alkali metals. These metals are all reactive and are rarely found in nature as pure elements. They are lithium, sodium, potassium, rubidium, cesium, and francium. Now, alkali metals are soft enough to be cut with a knife. Alkali metals are soft enough to be cut with a knife. Alkali metals have low density. Lithium, sodium, and potassium all float on water. The alkali metals are also very reactive as elements. They have to be stored in oil. This keeps them from reacting with oxygen in the air. The alkali metals also react with water to form alkaline compounds, as I've indicated earlier. This is why they are called alkali metals. The alkali metals all have one electron in their outer shell. This means that they are all found in group 1 of the periodic table. It also means they have similar physical and chemical properties. They can rarely lose the outer shell electron to form positive ions with a plus charge and an full outer shell. Now let's look at properties of alkali metals. The characteristic properties of the alkali metals are: 1, they are soft and can be cut by a knife. Softness increases going down the group. In other words, potassium will be softer than lithium, and so on and so forth. They have low density. They have low melting and boiling points. These properties make the alkali metals different to typical metals. However, alkali metals do share some properties of typical metals. For example, they are good conductors of heat and electricity. They are shiny. This is only seen when alkali metals are freshly cut. You'll see they are shiny, but after some time they get oxidized, so oxygen reacts with them, covering the shiny surface. The alkali metals generally become more dense going down the group. The trend is not perfect because potassium is less dense than sodium, so please note that. Now, as you may recall, water has a density of 1 gram per dm cube, which elements in group 1 would therefore float on water. Let me give you the density of lithium is 0.53. The density of sodium is 0.97. The density of potassium is 0.86. the density of rubidium is 1.53 and the density of cesium is 1.87. So my question is, which of these metals will float on water, given that water has a density of 1 gram per dm cube? Now let's look at the melting and boiling point of group 1 metals. The melting and boiling point of alkali metals decreases down the group. Lithium has a melting point of 181 and a boiling point of 1342. Sodium has a melting point of 98 and a boiling point of 883. Potassium has a melting point of 64 and a boiling point of 760. Rubidium, on the other hand, has a melting point of 39 and a boiling point of 686. Cesium has a melting point of 28 and a boiling point of 671. This is because as the atoms get larger, the attraction between the positive metal ions and the delocalized sea of electrons gets weaker. And so the metals become easier to melt and boil also. Now, let's look at reactions and reactivity of these elements. All alkali metals react with oxygen to form metal oxides. For example, sodium plus oxygen will produce sodium oxide. Lithium plus oxygen will produce lithium oxide. Potassium plus oxygen will produce potassium oxide. And rubidium plus oxygen should give us rubidium oxide. This produces a layer of dull oxide on the surface of the metal. As I indicated earlier, metals, when cut, they are shiny. However, because they react with oxygen, the oxygen coats the surface and thus producing a dull surface. The speed with which alkali metals react with oxygen increases going down the group. The reaction between an alkali metal and oxygen is an oxidation reaction. It takes place when an atom's outer electron is lost. The word equation for the oxidation reaction between an alkali metal and oxygen is alkali metal plus oxygen will produce alkali metal oxide. For example, lithium plus oxygen will produce lithium oxide. Sodium plus oxygen will produce sodium oxide. Now, I would like you to think about these equations. Lithium plus oxygen to produce lithium oxide. Can you write the word equation and also write the balance symbol equation for a reaction between lithium and oxygen to produce lithium oxide, and also between sodium and oxygen to produce sodium oxide, and also between potassium and oxygen to produce potassium oxide. Now, when you finish doing that, let's now go to how can we write ionic equation. Write the ionic equation for the oxidation of sodium atom. This will become sodium, giving rise to sodium ion, and 1 electron is lost. What is happening in this reaction is that the sodium atom loses 1 electron to form a positive ion with a charge of +1. Because oxidation is the loss of electron, the sodium atom has become oxidized. All of the alkali metals react vigorously with water. The reaction becomes more vigorous as you descend the group. It is an exothermic reaction. What is an exothermic reaction? An exothermic reaction is a reaction in which heat is given out. Reaction releases a lot of what? Heat. The reaction produces a gas that ignites a lighted splint with a squeaky pop. What is this gas? When green universal indicator is added to the reaction mixture, it turns purple. What does this tell you about the products of this reaction? Now remember, the reaction gives out a hydrogen gas. And remember, the test for hydrogen is that hydrogen relights, burns with a squeaky pop sound. Hydrogen burns with a squeaky pop sound. The reaction creates alkaline hydroxide ions. This is why the group 1 elements are called the alkali metals. The general equation for the reaction between an alkali metal reacting with water is alkali metal plus water will produce alkali metal hydroxide, and hydrogen gas is given off. Lithium, as you may recall, is the least reactive of the alkali metals. When added to water, it fizzes and moves around slowly across the surface of the water. Lithium plus water will give us lithium hydroxide plus hydrogen. When added to water, sodium, however, will fizz more than lithium and moves quickly across the surface of the water. The sodium melts as it reacts and becomes spherical and shiny like a ball bearing. The hydrogen sometimes catches fire because of the heat from the reaction. The word equation for this reaction will be sodium plus water giving us sodium hydroxide and hydrogen gas given off. When added to water, potassium moves across the surface of the water very quickly. Like sodium, it melts with the heat of the reaction. The reaction produces so much heat that the hydrogen catches fire. Now, potassium plus water will produce potassium hydroxide, and the hydrogen gas is given off as a result. Please note that the reactivity of the alkali metals increases going down the group. This is because the atoms of each element gets larger going down the group. This means that the outer shell electron gets further away from the nucleus. The further an electron is from the positive nucleus, the easier it is to be lost in a chemical reaction. And finally, this is why the reactivity of the alkali metals increases going down group 1. Now, let's look at alkali metals and how they react with chlorine. Alkali metals and chlorine react to form colorless crystalline salts called metal chlorides. The word and chemical equation for the reaction between lithium and chlorine are lithium plus chlorine will produce lithium chloride. So anytime an alkali metal reacts with chlorine, it will produce alkali metal chloride. Sodium plus chlorine, however, will produce sodium chloride. Now, safety precautions. When scientists carry out experiments, they have to take safety precautions. This minimizes the risks of harming themselves and other people in the working area. It is vital that chemists know the hazards associated with the chemicals that they use. Learn to recognize the universal chemical hazard symbols. When working with hazardous materials, it is important that the following precautions are taken. 1. Wear splash-proof safety goggles. 2. Cover exposed skin with long sleeves and trousers, closed-toe shoes, and long laboratory coats. Be aware of emergency procedures and equipment. Follow instructions and lab safety rules, and stand clear of reactions unless invited to approach by the one doing the experiment. And also often listen to your chemistry teacher whilst doing chemical reactions or whilst carrying out reactions in the lab. Now, to recap today's lesson, as I've indicated, group 1 elements are called alkali metals. They are found on the left side of the periodic table. They consist of lithium, potassium. They consist of lithium, sodium, potassium, rubidium, and cesium. Group 1 elements, as I've indicated also, they are quite reactive. Reactivity increases down the group, so you will expect potassium to be more reactive than sodium and sodium to be more reactive than lithium. They give out 1 electron to form cations or to form positive ions, and so as you go down the group, reactivity will increase. So cesium is the most reactive out of all of the group 1 metals. As I've also indicated earlier on, they react with water to form alkaline solutions, and that is why they are called alkali metals. Thank you again for listening to this presentation. I hope you've been able to understand Group 1 method. My prayer for you is that you will continue learning, you'll continue developing, and you will continue enriching yourself as you focus on your study till I come your way again. Bye bye. Keep learning and keep studying and enjoying chemistry. Bye bye for now.